Welcome to the BSides Hardware Hacking Village Lab number 2. This is Altbeer, and I'm going to walk you through this content. So we'll start with our design. So Lab 2 is focused around this particular circuit using a red, green, blue LED. This is the circuit schematic. So you'll notice that in the schematic, the RGB LED is shown as 3 different LEDs because it actually is 3 different LEDs built into a compact form factor, sharing, in this case, a common cathode, the negative line. So that's why the device has 4 pins on it. We're going to be hooking up resistors, 220 ohm resistors to each of the anode pins. And then we're also going to add a tactile switch. That's a fancy name for a button, connected to another digital pin, which we will use to read in and be able to control the colors on the RGB LED. So let's get into the physical layout. So what we're going to do is use the strip board that was provided in the kit to connect up the resistors, the LED, the button, and some wires to complete the circuits. So I have all of the strip board connection points detailed out in the PowerPoint presentation, which is on the screen now and also available on the website. The link will be provided in the video. So we're going to connect all of these up. One thing to note is when we go to connect up the LED, the cathode pin, we're going to need to bend that a little bit forward to get it to connect into a different place on the board. And as far as the button, one of the pins we're going to bend completely off that button because we're not going to use it and we don't want it to short out against one of the connections that's underneath it. So with that said, we will go ahead and start soldering this up. So let's show you what we have here. So we're going to be using the strip board that we used in LAB01, so it will still have the components from the first lab on it. These won't impact us in any way. We're going to work around those, and the code that we're using won't use these. You should also have your Arduino ready for when we go to program it. We have a 10K resistor, the tactile switch, 3 220 ohm resistors, the LED, and some wires. You'll need 3 pieces of wire for this. So let's go ahead and get started. We'll tin our iron up. And then we'll start with the resistors, because they're the easiest component to put in there. So we'll have 3 resistors that we will bend the legs into a U shape and connect them into the board. This first one is going into row 9 with positions in the L column and the O column. So O9, L9. And I use a pair of pliers to pull down the legs. That way they get nice and flat to the board, but you can use whatever works for you. Now we're going to skip the 8 row because that's where the cathode's going to be, and then we'll jump up to the 7 row and we'll go L7 and O7 for the pins. And these resistors are not polar, meaning they can go in either direction. So you don't have to worry about what direction the resistor is facing when you place it in here. And the last one is going on the 6 line, so L6 and O6. Alright, so now we have that ready to solder up. And just like with our previous lab, we want to make sure we hit both the pad and the pin at the same time. Looks like I got a little extra solder on one of these. We'll just bang that out. And once we get these done, we'll place our LED. Looks like one needs a little more. Alright, those are looking good. So now we're going to trim off these leads, these lead wires, so that they don't get in our way. And be sure not to cut into your solder joint. Ooh. Okay. Okay, looks like that looks good. We had one of those was sticking up a little too far. I just fixed it real quick. And now we will put in our LED. So the LED has 4 pins. The longest pin is the common cathode. So you can see the 4 pins. So basically, it's going to be red, the common cathode, green, and blue. And so we want to put it arranged to where that pin is going to go where there's no resistor, and we're actually going to bend it forward a little bit, like that. This way, it can go into the section up above. So we're going to put the 3 pins for the anodes into P, 6, 7, and 9. And then we're going to put the cathode pin into Q, 8. It takes a little finagling to get it, but once you get it, it should go down pretty easily. Alright, so we have that in place. Try to get it down as far as we can without damaging the pins, and then we'll kind of bend them out so that it stays in place. And let's solder those up. We can see we have some nice solder joints there, and we're going to trim those pins off. Okay, and so that's what we have. So the next thing that we're going to do is run a wire. So we're going to need a piece of wire to go from the R8 down to M12. This is to bring that common cathode to ground. So the first thing we'll do is trim some of the ends off so that we have some bare copper wire that we're working with. And then we'll bend these down to where they'll go into the board. And let's place it into the board. Just kind of arrange it where I want it. And we see we have our pins right there that we're going to solder. Oops. All right, let's try to get this steady. All right, and that looks good. We have both the wires are soldered in there pretty good. They are sticking up a little bit though, so I'm going to trim their ends off a little. Oops, wrong tool. Just this way it doesn't stab me later. Okay, so now we're going to work on the tactile switch. So as I said, this tactile switch has 4 legs on it. And actually I'm going to go back to the drawing for just a second to show you. So in the drawing you'll see that even though this is a single position, single throw switch, it has 4 legs. So basically 2 of the legs are interconnected on each side of the switch. And it's along the outer edge. So the pins that are on the same side are actually the 2 different positions, where the pins that are on opposite sides are interconnected. So we're going to bend off pin D in this diagram because we're not going to use it. So if we look at this switch, you can do it with your hand, or I use a tool, and we're just going to bend it back and forth until it comes off. And it comes off right like that. So now we just have 3 connections. And those connections are going to plug into our board. Like so. And so if we look at the diagram again, we will see that the connections that we wanted to plug in for the switch were in D1 and D3 and then G1, and that's what we did. So now we just got to solder that into place, and then we'll work the wires around it. And these pins, these buttons are tricky in that they don't have much there to solder. when they're in place, so we want to make sure we're holding it down. And to do that, I'm going to use a tool and then just make sure the button is laid on that tool so that I'm applying pressure to it as I solder it, and it's not going to fall out. And then I'm keeping pressure on there for a few seconds while the solder hardens up. And there we can see we have good solder connection, and we have our button is ready to go. So now what we have to do is run the resistor and then the 2 wires for it. So this is a 10K resistor. It's going to be our pull down resistor. And it's going to connect into C1, which is sharing the leg of that button. And then normally I'd put it in B1, but that seems to be too tight for this resistor to not be sticking way up in the air. So I'm using A1. So A1 and C1. And then we'll just leave enough room to get a wire in underneath it in B1. So something like that. It's a little up off the board so we can get that wire underneath it. And let's solder that up. Okay, then we will trim these wires off of it. All right, next we're going to run our power wire. This is the wire that's going to go from the 3-volt power source on the Arduino over to one of these button pins that'll allow us to pull up the power on the digital pin. So we're going to put this in this one pin that we broke the other one off to. So this is C3. And then it's going to go over to H2, which is where the 3-volt supply is. So we got a chunk of wire here, and we're going to trim the ends off. And we'll bend them down. And then we'll get it in place. So H2. And it's going to bend around to C3. And actually I got a little bit too much wire here. So I'm going to trim this off a little bit and we'll try again. Technically you can have longer wires like that, but if you want it to look nice, you try to get the wire as close to the distance you need as possible. All right, so there's my H2 coming over to C3. All right, before I solder this in, I want to show you the diagram once again. So this connection here is the one that we're doing for the wire, H2 and C3. And what this does, you can see it better on this on the schematic. Let me go to that schematic page. Yeah, so on the schematic you can see it better. What this is doing is this is the power line coming into that pin of the switch. And we're just wiring that in so that when we push the switch, it provides that power over to the D13 pin. And the 10K resistor there is just what's called a pull-down resistor. It makes sure that D13 is at a low value unless the button is pushed and we bring it a high value of voltage. All right, let's solder that up. And I just knocked it out. Yeah, and part of the problem with wires is they sometimes do not stick in the holes as well as components because you can't bend their legs out. So I'm going to try to apply pressure to it like I did with the other component on a tool. This one is being a little tricky. There we go. All right, we got it. So there's our wire, and we'll trim off the excess. And that did not work. So one of the things I always do to test the wires is to try to bend them a little bit, and that one broke off, so we'll have to put a new wire on there. So what probably happened there was when I was trimming the wire to get the plastic off of it, I probably cut too deep, and that left score marks in the wire so that when I pulled up on it, it broke right off. There was like almost no resistance there, so that would not have been a good connector, which is why I like to tug on them to confirm that. So this one I took care to not score the wire, and it's ready to go. But now we have to clean out these chunks of wire that are left in the hole. And what we'll do for that, for this big one, I'm going to use my pliers and apply heat until I can pull it out. And that other one seems to be a bit too small. So what we're going to do for that one is just press down on it with the soldering iron, pressing down on the center wire, and then we're going to bang it. And we can see if we can clear the hole. Looks like it almost came out. We'll do that again. Yep, that took care of it. There's that chunk of wire. Now we want to make sure that these holes are clear. It looks like that one is. This one has a little solder left, so we'll just do that again. We'll apply the soldering iron to the hole and then bang. And we can see that hole is nice and clear now. So we can put the new wire in. Let's go ahead and do that. All right, and we'll solder this up. And lots of people have lots of different desoldering techniques. Mine is just get it hot and bang the crap out of it. It seems to work. All right, that looks good. Let's trim off our extra. Yep, and that works. All right, so now we got the ground wire is the only one left to deal with, so that's going to take this resistor pin, and we're going to place this into B1, and we're going to bring it all the way down to the 14 row, E14, and that's because that's another ground pin on the Arduino. Even though the schematic showed everything connecting into D4, this is also a ground pin that we can use, and they're interconnected within the Arduino, so it's the same effect. We're bringing it to ground. Bend our pins and place it. So we have our B2 connection and there we go. And then we'll bring this over to E14. Apply pressure on here as we solder it together. Looks like I got a little bit of a bridge here. Take care of that. All right, let's trim the ends off, and this circuit should be done. And there is our completed circuit. Try to move this one a little, make sure, yep, it's good. Okay, let's move on to code. Okay, so for the code for this project, the first piece of code that we're going to do is just going to cycle the LED color modes. So what we're going to do for this is we're going to set all of the pins for the LEDs, and then we're going to just run through a for loop that assigns their color value based on an array that we create that has the different color values. So let me step into that, but first I want to plug in my Arduino. So I'm going to use my USB tester to make sure that I'm protecting my PC's USB port. And then we will plug in our Arduino, which you'll notice the Arduino is still running the code from the last lab, and that's fine because we're going to overwrite that. So let's take a look at our code in detail. So like I said, the first thing we're going to do is define the pins. So we have red, green, and blue, and because they're all the same LED, I labeled them LED2 underscore red, green, blue, and the pin numbers. Then we're going to have a global variable just called C. This is going to be our current color, and I'll explain that in a minute. In the setup, I have to set up these pins as output pins. And then we're doing our serial output at 38400 baud so that we can see what's going on in the serial console. In the main loop, I am going to set a delay time of 100 milliseconds. And then here is the array that we're setting up called color. And it's a two-position array, meaning that it's an array within an array. So we're going to have these arrays of three binary number, or not binary, integers, which I'm using binary, but they're actually an integer. But we're going to have three integers that represent red, green, and blue. And then we're going to have 7 elements of that. And this is our 7 colors that we're going to display on the RGB LED by turning on and off the red, green, and blue LEDs individually. So I called these colors 0 through 6. This makes up the 7 colors, the 7 elements in this array, and that'll be white, red, yellow, green, cayenne, blue, and magenta. And those colors are derived by turning on or off the red, green, and blue pins. And so that's the array that we're going to use for this. When we come down a little further, we also have a pin array. So our LED has 3 pins, red, green, and blue, and we're just calling out an array that lists out what those are so that we can use that array in the loop. So as we move down, we're going to print our current color that we're using in this main loop, just by calling it out and printing that. And then we're going to start the for loop. This for loop is going to run 3 times, and it runs 3 times because we have to set red, green, and blue. So we're going to digital write the LED number, so this will be 0, 1, or 2 for the 3 color types. We're also going to set our color, which is using the variable C, and then this iteration number, which will be 0, 1, or 2. So basically, we're going to set these colors based on C. It determines which one of these it gets, and then this array sets each individual one. And then we print that information out to the screen. And then the last thing we do of significance is we increment the color. So that way, the next time we run through the main loop, it will have the next color in line. So we do C+1, and we make sure that we don't overrun our array. So if C is greater than 6, we set it to 0. And then we print a new line character and set our delay to view the current color before we loop through this. So let us verify this code, and then we're going to push it to the Arduino. And when we push it, we should see on the left side of my screen, top left corner, the red LED that's blinking now will turn off, and you'll start to see the red, green, blue LED go through this cycle. All right, we're uploading the sketch now. That's the upload button. And we can see it's looping through all of those different color modes exactly the way we told it to. This is not controlled with the button yet. We will get that in the next code. This is mainly just cycling through all of the available colors that we want to play with. And you'll notice that these colors are just being set with a binary value of a 0 or 1. If you had hooked up the RGB LED to pins on the Arduino that support PWM, you could set these values anywhere from 0 to 255, the way we did in Lab 1 with that other LED. All right, so let's look at our next piece of code. So what we're going to do for this piece of code is, well, first I have to get it to open correctly. We're going to use the button to change the color. And let's actually look at the PowerPoint for this. So with the button, what we're going to have to do, in addition to sending outputs to the red, green, and blue pins, we're going to have to read an input from the button to determine if that button's been pushed or not. And then based on whether the button's been pushed or not, that's how we'll determine whether we increment the color or not. Okay, so let's load this code up. We have, we'll take a look here. The only difference in the top line is we're defining the pin for the switch. And then we have another variable in addition to C. We have our switch state or button state. And then in the setup, we're calling out that switch as an input pin. This section is mostly the same. And then when we get down to this digital read, that's where we're actually looking for the state of the button, and we're saving it in this variable. And then we print it to the console as well. So then based on that variable, if it is high, meaning it has a high voltage, so that button's been pressed, then we're going to go through this same increment code that we had before to increment the color number. And then we're going to print what that color is. And then we're going to display the color the same way that we did before, with a for loop to go through red, green, and blue for the LED. And then we'll have our delay time. So very similar to the other code. The only real difference is we're using the button to increment this. Otherwise, the color is going to stay the same each time it goes through this loop. So let's verify it, and we'll push it. I always verify first, even though it does a compile when you go to push, simply because it's a good practice. That way you don't push bad code to your Arduino. And now we see that it is solid white right now. So let's take a look at what's going on in our serial monitor. And we can see that the button, the switch, has a value of 0, meaning it's not been pushed. And the values that are being set on all the different pins are staying the same because our color is 0, that's white. So let's push the button and see how this changes. And we could see just for a brief second there, let me stop the auto scroll and go up here. We can see where that color changed from 0 to 1. And it happened right here, where the switch value was seen as 1, that's high. And then it changed the color, and now we're showing that new color. And we can do that again and again. Every time we want to change the color, we push the button, and it will see that button was pushed and change the color to the next color. And you can hold it down to press it lots of times and emulate the cycle code. And that is how we program a read of a digital device like a button. So that is the end of this lab. We were able to build our circuit for an RGB LED. We were able to complete that circuit with code to cycle the colors and then to read in the contents of a button and use that to change the code or the color of the LED via code. Thank you very much for attending this lab, and I'm sure I'll see you in the next one. Thank you.